I'm Anil Kumar. Let me once again thank all the members of our free Math Solutions WhatsApp group. They are providing excellent questions and also solutions. Here we'll discuss a question from Baharani, which I have copied, and then we'll see how to solve them within no time. So let me explain the concept also as we discuss the question. The question here is, a triangular wall with sides 300 meters, 400 meters, and 500 meters was built around a village. A cylindrical reservoir of capacity 100,000 cubic meters was to be built here with least height. Find approximate height of this reservoir. Now, we are given a triangle with sides 300, 400, 500, and that clearly indicates that the triangle is a right angle triangle, correct? So let me make a clear picture here. These are all rough sketches which will help you to provide solution. Now in this, if I am trying to make a cylindrical reservoir, that means circular base, right? So we have to inscribe a circle within this triangle, right? So, and we have to maximize the area of this particular circle. Is it okay? So let us say that this is our circle. Okay, let's make it like this. Okay, fine. So I'm making this circle. Made it very dark here. So that becomes the circle inscribed in our triangle. Now, we need to basically find the radius of this circle, right? You will notice that since we have a right triangle here, the radius r will be kind of like this, right? So these are tangents, right? This is also tangent r, correct? Now what you notice here is that the points, the vertices, gives you two tangents to this circle, right? So let's label this as A, B, and C, for example. Sides are 300, 400, 500, right? All are in meters. Now, if this is R, how much is this distance? Now, this distance will be equal to that distance. You do get the idea. Let's call this point as PQR. P, Q, and R, right? So these points. So we have a theorem which is based on the circle theorems, and that says that tangents from an external point to a circle will be of same length, right? So the idea here is that we have equal length of tangents from external point. Correct? So that is the theorem which we are going to use to solve this particular question. See how easy it becomes. So we know that C to R should be equal to C to P, since C is the point from where two tangents are drawn to the same circle. And how much can this be? Well, C to R is 400 minus R, right? It is 400 minus R, correct? As you can see here, this distance C to R and this is R, small r, right? Oh, we kept capital R, that's okay. So I've used capital R here. Let me make it smaller. Okay. So that radius. So that means that C to P is 400 minus R. Similarly, you will notice that AQ is same as AP. So AQ is equals to AP, which is 300 minus R, because this is R, right? Radius, this radius. So it is 300 minus R. So this side will be 300 minus R. But what we are given here, we are given a total length of 500, correct? Total length is 500. So that means that AC, which is 500, should be equal to 300 minus R plus 400 minus R. Correct? So we get 500 equals to 700 minus 2R. So 2R is 700 minus 500, which is 200. Correct? So R basically is 200 divided by 2, or just 100. So we know the value of R. Now volume is given to us as 100,000. Correct? So equate for volume. So volume of a circle, the formula is pi r square h. So we can say 100,000 is equal to pi radius square, which is 100 square, times height. Pi r square h is the volume, right? So volume is pi r square h, and r is equals to 100 for us. Correct? So using this information, we can get what height is, right? So the value is 100,000, it is 100,000 divided by 100 square means 100, 2 more zeros, times pi in the denominator is the height. Now, 4 zeros, right? 2 and 2. We are left with 10 over pi. So 10 over pi is slightly more than 3, right? So approximately you can say, well, about 3 point you can say 2, right? For example. Or you can just mention this as 3 meters, right? So we can say it could be around 3 meters for that particular volume. Is that clear to you? Right? So pi is 3.14. 10 divided by 3 will be 3.1 something. So we can say it is around 3. Is that clear to you? Right? So that is how we can find the answer, right? So it is less than 3.3, 3.2 meters. So that could be the solution, right? So that is how we could actually solve this particular question. If you want, you can round this to 3 meters. But I hope you understand the concept. The concept here is, whenever we have an inscribed circle in a right triangle, in that case, these length of tangents are same, and therefore 400 minus r, 300 minus r should be equal to the hypotenuse 500, gives you the value of the radius of the inscribed circle. Once you know that, then it's very simple to find the volume, pi r square h. Perfect. So that is how you will solve it. I hope it makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.